Okay, this is a higher tier non-calculator exam from June 2012. Question number 1. Sam wants to find out about the types of films people like best. It said design a data collection sheet, not a questionnaire, a data collection sheet. You need tally marks, you need totals, you need to have the types of films in. Fairly simple. Sam collected his data by asking 10 students from his class. This might not be a good way of finding out the types of film that people like. That's the interesting word there, because he's not finding out what types of film people like. He's finding out what types of film people in his set like at school, his class at school. So students in his class do not represent society. Also, the sample is too small, it's only 10 people. So any of those will do. Next one, question 2. Some paving slabs. It's 3.6 metres wide, 3 metres high, and the paving slabs have got sides 60 centimetres. What I did for this is just literally broke it up. I worked out that you get 6 slabs across, so that looks something. There's 3, 4, 6 slabs across, because obviously they're 60 centimetres, and you get 5 slabs up, so that will look something along the lines of there you go. So you can just count up how many slabs you need. So 6 times 5 is 30 slabs needed. So yes, he does have enough because he had 32. The paving slabs cost £8.63 each. Work out the total cost of 32 of them. I converted the £8.63 into pence, so 863 times 32. There's your workings. There's your answer you should have got. Next one, again, it's a functional question. It's question 3. It's got the star next to it, so we've got to show plenty of workings for ourselves. It's about delivery firm and parcels. This is bills on the graph. How much is the fixed charge? It starts at £10. So even if you deliver a parcel 0 miles, he'll still charge you £10 just for turning up. The next one is the functional bit. He's got a competitor called Ed, who delivers parcels at £1.50 for each mile, but doesn't have a fixed charge. Now this is really important. Compare the cost of having a parcel delivered by Bill compared to Ed. Now, you've got bills up the top here. It's £10, and you can work out how much it is per mile. In fact, it says so there. It's £1 per mile. For Ed, it's different. It's £1.50. The only way you can really do this, and don't just give one example. So, for example, if he delivered it 50 miles, it's cheaper with whoever. What you've got to do is work out if it's £1.50 a mile for Ed. For 10 miles, that's 15 quid, so there's a cross there. Let me just zoom in on the graph. For 20 miles, it's £30, so that's why I put a cross in there. And for 40 miles, it's £60. So what you can do now is get yourself a ruler, and you can connect up the lines and draw a line on the graph. So here we go, and it should start at 0, 0, and it should look something like that. You will always use a pencil, but I'm using this so it will show up a bit better. So there you go, there's his charge. So the comments you write are something along the lines of, if the distance the parcel has to be delivered is 20 miles, then the cost is the same, because that's where they cross. If it's more than 20 miles, then Bill is cheaper. If it's less than 20 miles, Ed is cheaper. And say where the data came from the graph above. Question number 4, stem and leaf diagram. That's what it should look like. The important thing is make sure you've got a key. Make sure these are in order, nice easy marks. I always count up the ones I've got here and check there's 16, because there should be 16 there. Nice and easy. Next one, some medicine. This is just a substitution question. It's putting numbers in a formula. It says here, so it's M is 30 and A is 40. Multiply them out, you get 1200 over 150. I've simplified it as the fraction, so you get that, 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 and that, and it ends up equaling 8 millilitres. Question number 6, ratio 1. She's got 25 millilitres of milk. How many shortcakes can she make? Well, you need 10 millilitres to make 12, so you times that by 2.5 to get to 25. So you times 12 by 2.5 and you get 30. So 30 is the answer. Robert's got this much stuff. Work out how much he can make, how many he can make. Work out how much he can make for each ingredient using this bit of data above. So for example, he's got 500 grams of sugar, so that's 10 times more than he's got here, so we can make 120 with the sugar. The butter, he's got 1,000 grams, so that's 5 times as much, so he can make 60. And do that for all of them, and whichever one is the least one, that's the most he can make. So the most he can make is only 60. Next one, timetables. This comes up loads. You've got to go through your 20 times table and your 24 times table. Find out when they first meet. It's at 120 minutes, so that's 2 hours. So if it leaves at 9, they'll next leave again at 11 a.m. Make sure you say a.m. because they do leave at 9 a.m. Expand the brackets. Fairly simple. 3 lots of 2y is 6y. 3 lots of 5 is 15. Put your minus in, you should get that. Factorise completely. So what does 8x squared and 4xy have in common? Well, it's 4x. You could say 2x, but to factorise completely, you have to put the highest amount on the outside you possibly can. So it's 4x. So 4x times 2x is 8x squared, and 4x times y is 4xy. Make h the subject of the formula. A couple bits and pieces here. First of all, times both sides by 10 to get rid of the divide by 10. And then divide by g to get h on its own. So there is your answer there. Question number 9. Transformations. Describe the single transformation. When I've marked this, some people have described 2 or 3, but it's a single transformation. I think it's quite clearly a rotation. Half a turn. Because it's half a turn, you don't have to say which way you're going, but you can if you like. And the important bit, most people always miss out, is around what point, and it's around 0.33. That's where it rotates around. Question 10, again another functional one up there, you've got your star. Work out how much your tickets cost. I'll let you read it. There's my workings. You've got to work out the percentages first without a calculator. So I broke 2.25% down to 1%, 1%, 0.25%. There you go. Same thing with the other one. Then you add on your fixed charge. For rail tickets, it was 80p. For cheap trains, it was £1.90. So that's that. Then I've seen which one's cheaper. Then I've written at the bottom quite clearly, rail tickets is 65p cheaper, 4 marks. Question number 11. Okay, right, here we go. Work out the value of x. We've got, it looks difficult, this, but it's not too bad. Right, first of all, state there's 360 degrees in any quadrilateral or 4-sided shape. So what I've written down is 360, that's the number of degrees, equals, and I've just copied out each of the angles up here. So 2x, add 3x, take 15, add 2x, and add 2x, add 24. So if you simplify that, add all the x's together and all the rest of it, you should get 360 equals 9x, add 9. So we're just rearranging the formula here. Take 9 off both sides to get rid of that, because we're trying to get x on its own. So that leaves you with 351 is 9x, divide by 9. There's my long division, because it's not an easy sum without a calculator. So x is 39 degrees. 3 marks for that. Jane has a carton of orange juice in question number 12. The depth of the orange juice at the moment is 8 centimetres, so that'd be roughly around there, I reckon. She's going to flip the carton over this way, so it lands on this side here. Work out the depth in it now. First thing you've got to do, the volume of the orange juice in the carton. So volume is width times depth times height. So because it's there's your width, there's your depth, and there's your height, because it says it's 8 centimetres deep. So the volume is 480 centimetres squared, or it is 480 millilitres if you want. So the carton now looks like this, because I've flipped it down. So the base is now 20 and the width is 6 and it is 10 high. So it looks something like that. So you've got to work out that, you know, that's your volume. So you can have, so 6 lots of 20 is 120. That's the bottom there times by the depth of it, how far it goes back. So how high can you go till you reach 480? It's 4 centimetres high. Question number 13. Calculate the missing angle. This comes up quite a lot, and it's good because it's dead easy. First of all, you need to calculate your angles in your polygons. I don't know how many angles are in an octagon off the top of my head, but I know how to work it out because you add on 180 degrees each time. So I've worked out here that's for 6 sides. First of all, it does say they're regular hectagons and octagons. That means that all the angles are the same in the inside. So for a hexagon, it is 120 degrees per angle. So I'm going to write that in, 120 degrees. And for an octagon, here's my workings, it's 135 degrees per angle. So I'm going to write that in. Please state there's 360 degrees in a full turn. So you need to do 360, take away that, so you do it here. 360, take 120, take 105, take 135, and that equals 105 degrees. And that is your missing angle, 105. Next one, question 14. A bit of bearings work on this one. Right, first thing you've got to do, work out the distance between L and H. So L and H, the photocopier went wrong. That should say, it doesn't, but it should say 7 centimetres. So if it's 7 centimetres, 7 times 5 is 35. If you've got a different answer to this, just check, because I think if you measure it, it's actually 6.8, which is wrong. So it's 7 5s are 35. Measure the bearing of H from L. Now the important thing here is that it is going from L. So when you measure it, you need to say that. So what you need to do is get yourself a protractor, which I've now got. Because we're coming from L, that means we're going this, oh, that's it. That means we're going this way. I'll draw an arrow, okay? So the angle you want is that angle in there. So put your protractor on, and it comes out to be 110. Right, boat B, we've got to draw our next boat. First of all, it's on a bearing of 040 from H. So this angle here is 040, or as you would know it, 40 degrees. You can do that with your protractor, and it's 20 kilometres from H. So 20 kilometres, look at your scale here, 1 centimetre is 5 kilometres, it's 4 centimetres, so it would be 4 centimetres up that way there. And you can even label it if you want, 4 centimetres. Question number 15, cumulative frequency diagram. Just zoom out a little bit so you can see it. There we go. Right, part A, use the graph to estimate the median weight. Well, first of all, you need to recognise it goes up to 60 and starts at 0, so the median is halfway, that is 30. So I'm going to write that on so you can see it, MEDIAN, and that comes down to 170 at the bottom there. So that is my answer, 170. Next page, here we go. 60 tomatoes from group A had a minimum weight of 153. We've got to box plot this, so there's my 153 there. Maximum of 186, that goes there. Remember my median was 170, so that's there. And you can work out your lower and your upper quartile by doing this. Your lower quartile is halfway between the median and 0, so that's here. That's my lower quartile, so that's down 15, and my upper quartile is up 15, upper quartile, and you read off where you meet them here. So lower quartile, that's my median, that's my upper quartile there. And you put those on your box plot here. There and there. I'll actually write on, that's your lower quartile, that's your median, and that's your upper quartile. You don't have to do that in the exam, but I do it to try and help explain it. Right, and Harry did not give fertilisers to tomatoes in plant B, just for the fun of it, I assume. Right, you've got to compare these two now. Be really careful what you say. I've written tomatoes from group B on average weighed less. And I look, because on average they do weigh less, because there's the median weight for B and there they are for A. And I've actually said in my answer, because the median for group B was 162 compared to 170 for group A. So I'm quoting statistics. Tomatoes from, and the other difference, because it's 2 marks, tomatoes from group B were more consistent in size. We know this because the range was 30 grams compared to 33 grams for group A. So what the range is the biggest, take away the smallest. So I've said these are more consistent because the range is smaller, and I've even stated it down here. Next question, simplify m to the minus 2. M to the minus 2 to the power 5, you write it out like that, and if it's ever like that, you add the index numbers, so that's why it's m to the power 10. Factorise x squared, add 3x, take away 10. It's going to go into 2 brackets, you need to draw your 2 brackets. Because it's x squared, just be x and x. Now you need to think of 2 numbers to go here and here that multiply together to make minus 10, but add together to make a positive 3. So to get 10, it's either 1 and 10, which won't work, or 2 and 5, which do work. So I'm going to put in 2 and 5. The only tricky bit now is getting your signs the right way around, because 1's negative. If we have a positive 5 and a negative 2, they'll add up together to make 3. So that's why that's a positive 5 and a negative 2. So there's your answer. Write down the value of 10 to the power 0. Anything to the power 0 is always 1. For example, 2 to the power 0 is 2 to the power 0 is also 1. 3 to the power 0 is also 1. Just check the camera. Yes, that seems fine. Carry on. Right. 6.7 times 10 to the minus 5 as an ordinary number. The way I do this is write out a load of noughts. One, doesn't matter how many, just write as many as you like. That'll do. And then put 6, 7 at the end. Right, we know the point's in there. So I'm going to count back 5 spaces, because that means it goes that way 5. So 1, 2, 3, 4, 5. So the point would go in there. So I can look at it again and think that's 0.1, 2, 3, 4 zeros. So that is my answer there. 0.000067. Multiplying numbers in standx form. Not too bad. What you've got to do is, first of all, the way I used to do this was write them out in full. So 3 times 10 to the 7 is there, 9 times 10 to the 6 is there. And let's say you've got, like when you multiply 30 times 30, you do 3 times 3 is 9 and bung your noughts on. Here it's the same thing. 3 times 9 is 27 and bung all your noughts on, and it's obviously loads of noughts. And then your decimal point is here, but the number of spaces you count back, so you're between the 2 and the 7 is 14. So it's 2 times 7 times 2.7 times 10 to the power 14. Question 18. Okay, we've got to enlarge the triangle by scale factor a half, which is a bit of a con, because that means make it smaller. Around centre, 0, 0. So that means everything's going to be heading down towards the centre and getting smaller. The way I do it is by the points. This point here, point A, is 2 away diagonally, so that's going to come back to this one here. Point C is 1, 2, 3, 4, 5 away, so it's going to be 2.5, so 1, 2.5. And point B is down 1 across 3, down 1 across 3, so it's going to be across 3 and step 1. So there's my triangle, and work out the area of it. Area is width, which is 2 times the height, which is 1.5, divided by 2, and that is 1.5 centimetres squared. So you can write it 1.5, or you can write 1.5 centimetres squared. But that's just the area for the triangle. That's base times height divided by 2. 3 marks. Question number 19. Probability should be quite nice and easy, this one. Just fill in the data. Well, if that's 0.4 of her winning, the chance of her losing is 0.6, and fill in these accordingly. Nice 2 easy marks. Work out the probability that Wendy wins at Hoopla and also wins on the coconut shy. So you want to go win, win up here. So you want to be doing 0.4 times 0.3. And I brought that down here. So 0.4 times 0.3. I know, I do this for a long time, that it's 0.12. A lot of people write 1.2, it's not. Or you could do, if you're not comfortable doing that, go 4 over 10 times 3 over 10, because that's 4 over 10. 4 tenths times 3 tenths is 12 over 10, and you could simplify it if you wanted. But the answer of 0.12 is ideal, but they will accept 12 over 100, because it doesn't say anything about how to give your answer, so that would be fine. Question 20, simultaneous equations. 4 marks for this. Say clearly what you're going to do, because the examiner would have marked probably about literally 200 of these, and he's getting fed up with it. So the easier you can make his job, the more marks he'll give you. I'm going to make the y's the same. So I'm going to do that by multiplying the top one by 3 and the bottom one by 2. So there you go. So the top one's by 3, bottom one by 2. And to get the y's to 0, you need to add, because one's positive, one's negative, so you need to add them. So I come up with 23x is 69, divide by 23, x is 3. So I put that down the bottom. So now we know that x is 3. We're going to go back and substitute x equals 3 into one of the equations. I've chosen the first one. So 5x add 2 is 11. That's what we had to start with. Well, I now know 5x is 15, because x is 3. So 15 add 2y equals 11. We're just rearranging it to get y on its own now. Take 15 off both sides, so 2y is minus 4. Divide by 2, y is minus 2, and that is your answer for 4 marks. Question 21. Circle theorems. It's functional, again up here, so explain yourself really clearly. D, C and B are points on the circumference of a circle. So D, C and B are all on the outside. A, B and AD are tangents, and angle DAB is 50 degrees, so it says so there. Work out the size of angle BCD. So that's why I put a question mark on that one. There's some things you've got to know. An angle between tangent, and this is a tangent here because it hits the line, and the radius, so that's obviously the radius there, is always 90 degrees. So that's why I've labelled that one 90 and that one 90. So angle DOB, which is this one in here, I can work out because it's 360, because it's a four-sided shape, look. Take away 90, take away 90, take away 50 is 130. But you need to be saying quite clearly that angles in a quadrilateral add up to 360. So that's 130. There's another circle theorem rule there, is that if that angle is 130, the angle at the centre is twice that at the circumference. So what that means here, because that angle's at the centre, it's twice that one over here. And these radiuses or radii can go off any direction they want. This will always be true because this one gets bigger, that'll get bigger, but this gets bigger by twice as much. So it's 130 divided by 2, which is 65. Nasty question. Question H, histograms. As soon as you see histograms here, the first thing you should be doing is writing down your formula for frequency density, which is frequency over class width. You see what I've done here, I've worked them all out. Obviously there's your frequency, your class width there is 5, 5, 10 and 20. So 5, 5, 10 and 20. So the highest one it goes up to is 5, so I have to put a scale on my histogram. So it goes from 0 to 5. You do this in pencil, I've done it in pencil, you can see it. So you plot the class width against your frequency density. So it's 3, 5, 3.6 and 1.6, 1.2 rather. So you get 3 marks for doing that. Nice and easy. Work out an estimate for the number of cars with a speed of more than 85 kilometers an hour. It's quite handy because we're just using this bit here. 85 is here, onwards. So 85 kilometers or more is in this range up here. So what you need to do is figure out that that is 3/4 of this whole amount here. So you need 3/4 of the number of cars in there. So there's 24 cars in there, so 3/4 of that is 18. So it's 18 cars that go faster than 85 kilometers an hour, or that we estimate that go faster. Question 23. Fully simplify this one up here. First thing you've got to do is factorise the top and factorise the bottom. I'm not going to go through it now. You can look up factorising, but that's what you will get. And then all you can do is notice that this one here and this one here cancel. So you're left with x add 4 over 2x take away 3. So you've got to factorise the top and the bottom to solve that one. The next one there, write the formula, or the expression, as a single fraction in its simplest form. What you need to do, like you do when you're adding up any fractions, is get the bottom numbers the same, or the denominators the same, by cross-multiplying. Well, you don't have to cross-multiply, but that's what you can do. So step 1, I've made the denominators the same, because I've literally multiplied them by each other. So I've multiplied those two by each other. So I've also done that, and I've also multiplied it by that as well. So that's where we get this from. Now, let's say we're adding up 1/4 and 1/4, it would be 2/4. So we're adding this up, the denominator stays the same. So that's fairly simple. We're going to expand the numerator and then add it up. So what this is here, I've expanded the top bit. So let me talk you through it. That's 4x take away 8. So 4x take 8. Add 3x. Add 3x. Why is that 9 times 6? Add 6. 4x and 8. Add add 3x, add 6 is 7x, take away 2. That is add 6. I don't know why I put a minus there, my mistake. Simplify that, you get 7x take away 2. So then you keep the denominator the same, and that's what you get, and that's your final answer. Express the recurring decimal 0.281 reoccurring in a fraction as its simplest form. Well, I've called that x, so 100x is that, because I've simply multiplied it by 100. What I'm going to do now is take one away from the other. So I'm doing 100x, take away 1x from here. It gives me 99x. So that, take away that, is 27.9, and there's nothing reoccurring anymore. Because I want to get this as a whole number, not a decimal, I've times both sides by 10. So that's 990x equals to 179. So the basic formula is, if you look at it this way, you want to get x on its own, so divide both sides by 990, it leaves you with this, but it does say in its simplest form. I notice that 9 goes into both of these, and so you can simplify it to 31 over 110. 3 marks, not easy. Next. Okay, the diagram shows a solid metal cylinder. The cylinder has a base radius 2x and of a height of 9x. The cylinder is melted down and made into a sphere of radius r, because radius is always little r. Okay, find an expression for r in terms of x. Sounds complicated, but we can certainly pick up some marks out of this because it's a 3-mark question. First thing you need to know, the formula for the volume of a sphere is on the front of your exam paper, so get that copied down. The one for the volume of a cylinder isn't, but to be fair, you've got to know that it's the area of the cross section times the height, so pi r squared times the height. So what we've done here, my area of a cylinder is pi times a radius squared times the height. So it's pi times, the radius is 2x, so it's 2x squared times the height, so that's 9x. What I've done, I've squared my 2 here, so that leaves me with pi times 4x squared, because that would, I suppose that would technically be in brackets. 2. And the height is 9x. Simplify it, you get 4 times 9 is 36 pi x cubed, because it's x squared times x, so that's where the x cubed comes from. Right, so we've got the formula for a sphere here, 4/3 pi r cubed equals our volume of a cylinder, and we're going to try and get the r on its own, so that's what you've got to try and do, is rearranging it. So divide both sides by pi, there you go, and divide both sides by 3/4, so you get rid of that, and we do 36 divided by 4/3, my mistake. If you divide both sides by 4/3, that goes, so you just left with r cubed. 36 divided by 4/3, try and remember that 4/3 is 1 1/3. So how many 1 1/3s go into 36? It's 27. When I get r on its own, so you cube root both sides, so you get r equals 3x, because the cube root of 27 is 3, and the cube root of that is just x. So it's r is 3x. Not easy at all. Question 28 and 29 to finish up with. Graphs. Y is equal to the function of x is shown on each of the grids. All right. So on the graph, sketch the grid of y equals the function of x minus 3. There's certain things you've got to know. If it is inside the brackets, like it is here, what's happening to x, it's going to, this graph here, the original one, is going to be shifted either way. You'd think because it's minus, it would go this way, but it doesn't. It does the opposite, so it moves 3 this way. So all I've done is move the points 1, 2, 3, 1, 2, 3, and 1, 2, 3. 2 marks. The next one, look at what it's the formula for it again. Sketch the graph of y equals 2, the function of x. If it's on the outside and it's multiplying, it basically makes it a little bit steeper. So you've got to come down here. It doesn't go any deeper down, it just goes down here and ends up looking like that. Very nasty question for the M1.